Off by a little bit. Okay.
5.98.
How much energy does a satellite mass 100 kilograms have in orbit 1.2 meters 1.2 times 10? 510 number 5.
On back.
I bruised my page.
How much potential energy does a satellite have mass 100 kilograms have in orbit 1.2 times 10 to the negative times 10 to the 7th meters from the center of the Earth relative to the surface of the Earth? Okay. So potential energy is always a difference, right? We kind of casually ignore the fact we set someplace to be 0. This time the Earth is 0, but we're always going to measure relative to the universe being 0. So we're going to have to do a little bit of work. We're going to say potential energy, relative potential energy is the difference between the two places we're talking about, right?
Why can't we just say
What's the acceleration of gravity in space? Can you use G?
No, but you can use the centrifugal force. How much force you're getting towards the middle.
If it's an orbit, we're talking about two objects just sitting there. We don't even have an orbit.
Why can't we use the gravity?
We have to. But we have to use
exclusively
G. That's fair what G is. G changes as you go up, right? It's an integral. You know, if you think about graphing G versus how far you are from the surface, it looks like this, right? You get less energy going up from here than you do for this little stretch, right? So here we go. It's G M over R negative minus negative G M over R.
Why?
What do you mean why?
Why are there?
Relative to the surface.
Relative to the surface of the Earth. We're asking how much do you gain going from the Earth to this height?
Yep. That's how the question they had on the 7. Number 7.
So far so good? So if I'm in orbit, I've got negative 6.67 times 10 to the negative 11th. Mass of the object's 100. Mass of the Earth is what? Is it on the formula sheet?
Yeah, no, it says
5.98 times 10 to the 10 to the 24th.
That's what it is, so it's good it says that. What?
That's G.
That's just what it said on the front page. On the other front of
Yeah, that's what it is.
That's
Okay.
what it is.
The mass of the Earth. Okay. Divided by the radius.
Why is it a negative 11?
Because the universal gravitational constant has been negative 11 since we introduced it the first time.
Oh, that's G. That's what I was asking.
That's capital G. Yeah. Okay. Then the radius would be 1.2 times 10 to the 7th. Agreed?
Why can't you?
Minus. Why can't I what?
Why can't you just combine the two distances?
Because it matters where you are. How much energy you get going from place to place. Because the amount of energy, let's say, this is the curve, right? For force versus distance. Going from here to here gives you more energy than going from here to here. So it matters where you are, even though you go the same distance, how close you are to the Earth makes it harder. Lifting off of the Earth is much harder than going from space to someplace else. That's why we're talking about building a base on the moon just to go to Mars.
Do you think we can go to Mars?
We can go to Mars tomorrow if we want to. We just don't want to.
Oh, really?
Yeah. It costs too much money, and the risk is a little high.
Why is that not like the most important thing to do?
Because most people think things like poverty and peace are bigger.
The ocean.
I say that. I'm with you. But the funny part is, I say that absolutely, but I'm with you. I think.
Eventually,
The ocean.
Because eventually our planet will just become uninhabitable, right?
Well,
Okay,
but not real soon.
But like, we gotta get started.
What? Look.
I think a left.
Mitchell, the truth of the matter is, the real value of going,
Times 10 to the 6th is what?
that would be the radius on Earth.
Okay.
So this is our high point minus our low point. Now what's interesting is you see the negatives, you go, what? But the minuses are going to take care of themselves because you have fallen less to get to here than you have to here. So when you put a minus and negative, this becomes a bigger positive than this one.
I got
which is weird.
Huge freaking number.
Well, it should be a good sized number. I don't know about huge.
Well, the answer's on the sheet, Mitch.
Is the answer on there? Did I get it right?
Good job. I didn't degrees.
It's another.
I got, instead of 3.1, I got 2.9.
I got
It's not like.
11 times 100 times 5.98 exponent 24 divided by 6.4 exponent 6. I got 9 point something.
Yeah.
9.56?
no.
No. 4, 5, 6, 7, 8, 9. 9.
That's not,
That's
That's not right? How's that not right?
because that's not the answer you give on your sheet.
It's not your answer either. Huh. 6.67 times 10 to the 11 times 100 times 5.98 times 10 to the 24th divided by 1.2 times 10 to the 7th plus
Dude, I think you must have added them.
6.67. I have to add them. Minus the negative is plus.
I know, but it's a negative.
Oh, I didn't put a negative in front. You're right. Thank you. Let's go back. See if I can fix it. Thank you. Shift insert negative. Love the Casio. Enter. How about 2.9?
That's what we got.
2.91 times 10 to the 9th, is it still?
Yeah.
9th joules.
We should start a restaurant.
But, so your sheet is
2.91. My sheet's wrong? All right.
You might have used 6.0 though instead of 5.
I might have. Am I close?
It's 3.1
Very likely.
instead of 2.9.
I also might have used 5.78? Whatever it actually is. All right. What I probably did, and I haven't told you about this, but these two numbers and the radius of the planet is a number I theoretically am supposed to know. I don't know it anymore. That's
Is
scary.
number 6 you do the exact same thing.
Yep. All right, where did I put down the sheet? I put it down someplace. Where did I put on my sheets?
Okay,
Thank
so
you.
Can you do number 7 after that?
Do number 7 after that?
Yeah.
Let's do number 7. 7. How much potential energy does a stationary satellite with an altitude of 2.0 times 10 to the 6 meters over the surface of the moon have relative to the moon? Surface of the moon. Okay. Negative GMM over R minus negative GMM over R. Agreed? Okay. So I got negative 6.67 times 10 to the negative 11th. Mass of the object. That's a bummer. We don't have the mass of the object. Well, we're going to do it in terms of M then. It's a bummer. Okay, mass of the moon. 10 to the 22nd, all over the radius. That would stump you, just the mass of the object.
I wasn't doing potential energy minus potential energy initially
Okay.
for homework, but.
So 3 points. So watch for this one. This is 3.74 times 10 to the 6th. Because it says above the surface, you have to add this, the radius of the planet too, radius of the moon as well.
Okay.
So then 6.67 times 10 to the negative 11th. Mass of the object. 7.4 times 10 to the 22nd. All over radius of the moon, which is 1.74 times 10 to the 6th. All right. See if I can do it right this time. Negative 6.67 exponent 11. That should be negative 11. Times 7.4 exponent 22. Divided by 3.74 exponent 6. Plus.
Wait, why do we have those two?
I didn't give you the mass of the object that's orbiting.
Wait, the moon is really massive.
Yeah, it's 1/100th our mass.
What is the gravity?
1/6.
Yeah, but Mr. Resney, how much more do you think you could lift on him? Like, say
Six
you're trying to
times
Six
as
times as much.
Yeah, no, but like, well, I mean, specifically a steel beam. How much? How much steel beam?
What length of a steel beam that's
Yeah.
foot wide could you lift?
Like a
Wait, no.
normal.
Not very much, like 6 feet. Or like 8
Well, how much can you lift?
Well, no,
Not that much.
I mean in general. I mean, like, I think it's not that heavy.
How much can you lift?
How
200
heavy-
pounds, 300 pounds? Give me a number.
200 pounds.
Let's
200
say,
pounds.
Let's say that the
You think you can lift 200 pounds?
That's just like a general.
Okay, let's just say 200 pounds on it is what? This
So you
person
need 1,200 pounds on.
Yeah, that's not that much
Yeah,
steel,
no, but
that's
that's
like a very short.
That's a small car.
Yeah, exactly.
Yeah, a car isn't made out of solid steel.
No, but
a
like,
construction.
no, but like all of the code together, how much steel do you think that would be? Because if you were trying to build like a weird thing,
All right.
everybody like, you know.
Physics is great. I got a weirdly negative number that shouldn't happen. What do you guys get?
Wait, couldn't it be a product of the fact that we don't have a mass? And they're all being recorded.
No, because the mass is in both of them.
We can always be
All of our stupid conversations.
It would be negative.
I remember.
It shouldn't be negative.
Yeah, because you're adding a smaller number than the first negative number.
Yeah, but the bigger number on the bottom, bigger number makes it smaller.
Yeah, right.
No, I'm wrong.
So it should be positive, right? So this should be bigger than this in total. So this should be, I get a positive number. I'm getting a negative number. Why am I getting a
Let me
negative
see,
number?
let me see.
Probably because I typed something in wrong. Oh, yep, I did. Very last thing. Ah, crud. That's where I got the answer in. Darn it. Should have done it from the beginning.
Gee, dang it.
Gee, dang it. Exponent negative 11 times 7.4 exponent 22 divided by 3.74 exponent 6. That's what I did last time. 6.67 exponent negative 11 times 7.4 exponent 22 divided by 1.74 exponent 6. I got a positive number now. It's a good side. How about 1.52 times 10 to the 1, 2, 3, 4, 5, 6 joules.
So whenever we're dealing with potential energy regarding,
M.
Yeah,
Thank
that's true. Can you give us an M?
just
No, 7's gonna be easy.
Can we do 8?
Let's do 8.
Is there a place?
I'm gonna pause it all. I want you to go ahead and do 8. See if you can do 8 without me talking
I
to
don't even know what to do.
I already tried.
you. You don't know how to do it.
D equals
Yeah, you
1
do.
half AT squared.
All right, I'm gonna do it, but I'm gonna be really sad. Energy before equals energy after. The energy before we just said there's 1.52 to L times 10 to the 6th M. Is energy before, that's potential. Energy after is kinetic.
M's cancel.
Be really bored with that one by now.
Oh. Okay.
That's quite quick.
Yeah, that would be painful. That's high orbit into the surface of the planet.
It's not going that fast.
How fast is it going?
1,743
That's
per
pretty fast.
second. Oh, per second. Okay, that's fast.
That's,
All right.
that's 3 times a bullet. That's enough to leave a. Yeah, it's enough to.
Okay.
With the information
Hurt.
from problem 7, what is the
You
acceleration
survived that
of gravity on the
What's the stationary gravity of the moon?
GM over R?
It's
Yeah.
we force of weight is equal to force of gravity. Mg is therefore equal to gmm over r squared. Agreed?
Anne was correct.
So this m cancels out because we don't care about the mass of the thing falling towards it. So we're going to go g equals 6.67 times 10 to the negative 11 times the mass of the moon. 7.4 times 10 to the 22nd. All over
R squared.
r squared,
Just
which
the
is
radius?
1 point, which is radius, because that's what's on the surface, right? That's just center to center. When we're talking about acceleration of gravity, right? It's the center of whatever object we're talking about to the center. And you got to be close to the radius in order for this calculation to matter anyways. Which is why we have to do the calculation different when we go higher. Okay, April 1st, when Mr. Eppolito leaves the room for 20 minutes, we'll go somewhere else and finish our class.
Maybe
A lot of things to figure it out.
we should just go like on a field trip.
We'll just go someplace else
Yeah,
and
we can
finish the
just go to
class.
like Jennings or over
Ooh,
or
that place
something.
is scary.
Unless it's a test. Unless it's a test.
This does not make it a test.
The problem with going to James L's room, sometimes he likes to skulk in this hallway, so it's kind of tricky to.
Yeah, we gotta go down.
We gotta maybe we have to keep a lookout for him.
No.
Right.
All right,
I got a very low number.
I got 1.63.
we just recorded that. What's the